Hello, grade 9. How are you today? I hope you all are safe and well. Today our lesson about how can we make salts using acids and carbonates. Before I mentioned how can we produce or make salt using acid and alkalis, but just I gave you a general idea about it. We have several ways of making salts. One of them is acids with our carbonates, compound of carbon. So please grab your highlighter and follow me. Making salts, acids and carbonates. Killing fungi or fungi. Fungi can seriously damage crops. They reduce crop yield and crop quality. The meaning of yield, that means the spreading or production of the crops and the quality of the crops. Fungicides destroy fungi. Some farmers use fungicides from natural sources such as the neem tree. Some farmers use fungicides that are made in factories such as copper sulfate. So there is a natural source, like a kind of plants or kind of trees called neem tree, and if it's something manufactured or something synthetic, they're using copper sulfate. Copper sulfate is blue in color and formed from crystal, and it's kind of salts. So here in these two pictures we have different about the leaves and about the seeds or the fruits, sorry. Different fungi attack different plants, causing damage to their leaves, seeds, or fruit and roots. The fungus on these grapes can be controlled using copper sulfate. So here we can find in this picture we can see the fungi is on the grapes, and here that makes it on leaves, makes it yellow and damage the leaves. And sometimes it can damage the roots also. So how can we make copper sulfate, or how can we get copper sulfate? We can get copper, or we can take this metal and reacted with another compound or acid to produce salt. So we have three ways to do this. Copper sulfate is a salt. It's made in the reaction below. So we have three reactions. First, we can choose sulfuric acid with copper, or sulfuric acid with copper oxide, or sulfuric acid with copper carbonate. So if we are using sulfuric acid with copper only, which is a metal, that will give us copper sulfate plus hydrogen. The acid must be concentrated and the temperature high. So I need you to think about this and give me your answers. Why we should use concentrated acids and we should increase the temperature to make it high temperature. Reaction 2. Sulfuric acid plus copper oxide give us copper sulfate plus water. In this case, dilute acid may be used. Okay, this is another question. Why we use diluted acid instead of concentrated one? Sulfuric acid plus copper carbonate give us copper sulfate plus water plus carbon dioxide, and here dilute acid may be used. On a large scale, copper sulfate is made in reaction 1 and 2 at school. You can use reaction 2 and 3 to make copper sulfate solution. Reaction 1 is too hazardous. So here, why the first reaction is too hazardous, too dangerous? The meaning is hazardous, that dangerous. So why it's dangerous? Sulfuric acid is corrosive if it's concentrated, of course. This is first one. And also, copper sulfate is a powder. If we want to extract it from the solution, we need to evaporate it and extract it as a salt. Copper sulfate can cause irritation for the lungs if it's inhaled, or can damage the eyes if it's splashed inside in the eyes. So that's why it's hazardous. And also high temperatures can be dangerous also, okay, for in this reaction. The chemical reaction. Cicera plans to make copper sulfate solution from sulfuric acid and copper carbonate, so he chose the second reaction. Here in this picture on your left, he's using a beaker to mix copper carbonate and sulfuric acid. So when they are reacting together, the carbon dioxide will fizzes out as bubbles out of the mixture. And then he measures out 25 cubic centimeter of acid. And how can we measure this accurately? Of course, we have to use measuring cylinder instead of beaker. Then we can pour it in a beaker. So here he pours it in the beaker. Then he added 1 spatula measure of copper carbonate powder, known quantity or known amount, and then carbon dioxide gas forms, and the reacting mixture bubbles. Cicera continues to add copper carbonate. Eventually, no more bubbles form. The reaction has finished. In this case, we have copper carbonate solid inside the beaker, and we have the solution. So how can we separate the mixture, or how can we separate the copper sulfate from the mixture? First, inside the container or inside the beaker, we have copper sulfate solution, and we have solid copper carbonate has not reacted, like the residual amount. So Cicera filters the mixture to remove solid copper carbonate from the mixture. We mentioned previously, when we make salts inside the mixture, if we have unreacted solids, we need to use filtration method to extract or to remove the solid from the solution. And then second step, we need to evaporate the water from the solution to get the salt. But not all the time. We should not evaporate it the whole time or heat it the whole time. We should just heat it for a while, then leave it in a room until the whole water evaporates and the salt remains. He collects the copper sulfate solution in an evaporating dish. Cicera heats the copper sulfate solution over a flame. Some of its water evaporates, some of the mixture spits out. Cicera removes the evaporating dish from the heat and places it in a warm room for a few days. The remaining water evaporates, blue copper sulfate crystals are formed. So if you just kept heating the mixture to the boiling point and you just continue to heat the mixture, sometimes you will speed up the boiling and the evaporation, and you will lose some of this salt, as like if it start to bubble, the solution will be out sometimes, like as the splash or drops of this water solution. And also sometimes we cannot get the crystals. If we want to get the crystals, we need to keep it just to calm down, like if it evaporates very slowly. And of course we cannot leave the source of heat for a long time, for days, on like a weak flame or something. No, in this case we have to heat the mixture and to at least for the half of the solution to evaporate. Then we need to take it in a warm room to complete evaporation there slowly. After a few days we will see crystals formed. Evaluating and improving methods. Cicera makes a smaller mass of copper sulfate crystals than expected. He lost some of the product when heating the copper sulfate solution. Cicera decides to improve his method. He repeats the whole experiment. This time he doesn't heat the copper sulfate solution over a flame. Instead, he uses a water bath. This heats the solution more evenly. The solution does not spit. Sisera ends up with a greater mass of crystals. So how did he discover that he lost some of this copper sulfate crystals or copper sulfate solution? First, when he started this experiment, he measured the volume of the liquid, the solution, and he measured the amount of the acid, and then he measured the amount of copper carbonate that he used. After this, when the reaction happened, he measured the amount of the salt, which is copper sulfate crystals. If he found less value or low value, that means he lost some of it. So each time you have to measure you have to make your quantities and known quantities. You cannot work with unknown measurements. You have to measure everything before the reaction or before the experiment and after the experiment. So now what's the pattern of the reaction now? When a metal reacts with a carbonate, any kinds of carbonate, any compound of carbonate, three products will form. First, a salt, carbon dioxide, and water. So we can get the salt by evaporation of the water, and carbon dioxide will bubbles out. So the equation shows some examples here. We have compounds of carbonates and with acids. So if we have hydrochloric acids with copper carbonate, we will get copper chloride and carbon dioxide with water. If we use nitric acid with magnesium carbonate, we will get magnesium nitrate as a salt, carbon dioxide plus water. If we use sulfuric acid with zinc carbonate, we will get zinc sulfate as a salt, carbon dioxide gas and water, and then we can evaporate the water to get the solution. So now let's go to the summary of the lesson. Making salts, acids, and alkalis. Make salts from acids and carbonates by first reacting an acid with excess metal carbonate, filter to remove unreacted metal carbonate, and then we should heat to remove the water to get the crystals. When a metal reacts with a carbonate, three products are formed: salt, carbon dioxide, and water. So this was all about the making salts from using acids with carbonates. I hope you understood the lesson. Don't forget to write these notes in your notebooks, and don't forget the yellow box. I hope to see you soon, safe, and we will meet in a new lesson. Bye bye.